Yeah, so basically, there's N cows that would like to take a daily walk around the fence. Yeah, and then there's fence posts, and then a cow might like brush against the fence post. And basically, what the farm is like, it's like a 2D plane. And all the sides are parallel to X and Y axes. Yeah. And then you have the guarantee that at each fence post, there's exactly one horizontal one. And then basically they're perpendicular, right? So there's exactly one horizontal and one vertical at each fence post. Yeah. And then a cow needs to get from some start point to some end point. Yeah, so cow needs to get from some start point to some end point, and it's always going to take the shorter path to the end point, right? And then yeah, and then it's asking for each fence post. Yeah, so it's asking for each fence post, how many cows are going to touch the fence post, right? And then there's like, yeah, coordinates are up to 10 to the 9, and then there's p posts where p is up to 2 times 10 to the 5, and you're given a 3-second time limit. Yeah. So let's talk about how to do this problem. So first thing the first thing is that the input points are not given in order. So you need to, yeah, so you need to figure out how to do it in order. Yeah, and then yeah, I think like all the subtasks require you to be able to put them in order. So this might have been, yeah, this might have been a challenge for many people, just doing it in order, because like all of the subtasks require you to figure out that step. I haven't really tested, maybe or maybe not. Maybe you could like yeah, maybe you can choose some certain cases. Maybe certain cases might pass if you do it, if you assume they're in order, but I'm not sure. So observation for how to put them in order. So how to put them in order. So note that like at each fence post, it has to be perpendicular. So you can't have anything like this, right? So for a certain X value, consider all the fence posts that are at this, or I guess it's Y. Yeah. For a certain Y value, consider all the fence posts that have this Y value, and consider the leftmost fence post. Since there has to be a perpendicular intersection, that means there has to be a fence that's horizontal. And since it's horizontal, you can't go to the left because you have to connect to some other fence post. So you have to go to the right. And since the fence post connects perpendicularly, you can't continue on. So you go to the next one, and then you have to connect these two. So you can show that if you fix X or you fix Y, where there's any fence post, there's always going to be an even number of fence posts. And then you connect the first one to the second one, and then the third one to the fourth one, and then the fifth one to the sixth one. And then you do this same thing in the X direction, or if you fix X. So you're going to have some even number of posts, and then you connect the first to the second, third to the fourth, and then fifth to the sixth. Yeah. Yeah, so that's an observation that yeah, they require to be able to solve it. Yeah. Yeah, this might have been a bit tricky to observe. Yeah, that's how you order the points. Yeah. That's how you draw the segments, right? And then you can order the points. And then now let's talk about how to answer the queries. So the query, it's like you have some start point and some end point, right? So consider the start point, right? So either it's going to be on a vertical segment, potentially both. Either it's going to be on a vertical segment or it could be on a horizontal segment. So one way you can check this is you can have like one map that stores like the vertical segments and another map that stores the horizontal segments. So let's say the start is like X and Y, right? And you want to see which segment it's on. Yeah. So yeah, so basically you can have like, yeah, you can have like map from int to like, you need like to store the segments. Yeah, I think it is very implementation dependent. Um, uh, like you could store like the lower endpoints of the segments and then also the index. So it could be like uh set pair int uh and then segment at some part X. So basically the key will be X value and then the value will be like the segments. And then you could have a similar thing for Y segments. And to check if it's on a vertical segment, you can just index add this X value and then do a binary search. So some kind of lower bound on your set, or I guess you could also use a vector and just do lower bound to binary search, right? So with these kinds of storing these kinds of segments, you can find for the start point and the end point, which segments they belong to, right? And then you can, yeah, and then it's like, yeah, it's a lot of implementation details, but you have to find like the nearest segment that's counterclockwise to the start, and then the nearest segment that's clockwise to the start, and then counterclockwise to the end. It could differ depending on implementation, and then no, figuring out which way is shorter, you have to do prefix sums. So like this compute distance using like prefix sums, like the distance from one station to another station. That's going to be like a sum of a subarray or a sum of a few subarrays. So you can do this using prefix sums. It's a lot of implementation detail, but yeah. And then after you do that, then you know whether to go clockwise or counterclockwise, right? So yeah, if the thing has like 9 points or something, and then this is 8, you're gonna touch stuff. So 9, and then this is 1 again, and then 2. So let's say that your path, you're gonna touch this one, this one, this one, this one. Then it's a similar thing that we did in problem 3. So you want to maintain like the frequencies of how much each thing is touched. So basically you're adding, so if you're touch 8, 9, 1, 2, then it's like add +1 to the range 8 to 9, and then some frequency array, and then add +1 to frequency from 1 to 2. And this is not fast enough naively. This will be like O(n) squared naively, but we can do the similar idea that we did earlier. So let B of I equal A of I minus AI minus 1. And then we can compute B of I, because this is just like adding -1. If you have X, Y, it's like adding -1 to BI plus 1, and then adding +1 to BX. Sorry, adding -1 to BY plus 1, and then adding +1 to X. And then you could take prefix sums to reconstruct array A. So this is, yeah, this is the same kind of thing we did in problem 3. Yeah. So you just need to be able to find the shortest path, and then know which ranges that you're going to visit, which ranges that the cow is going to visit. You're going to add +1 to this, and then add +1 to this, and then do this for all the cows. So basically, yeah, the idea is like find which segments you're on, and then find the shorter distance, and then determine which ranges of these stations you're going to go past. And then you add +1 to these ranges, but it's too slow naively. So you have to use these difference arrays to be able to do this in constant time. And then take the prefix sum, and then that's the total answer, right? So the answer will be prefix sum. So once you take the prefix sum of this, then you have the answer, how many times each station is visited. Yeah. So that's, yeah, that's the, yeah. Yeah, so that's the solution for problem 2. Yeah, I'll take any questions. Yeah. Yeah, about like how I rank the problem difficulty. I guess this year, like usually there, like each contest would have like one problem that's like kind of difficult, and like passing Fusco Silver has come down to like being able to recognize the standard problems and then getting subtasks from the harder one. I guess how I personally felt about this contest is problem 1 might have been like more standard. I guess you still have to be a bit careful the way you implement, and make sure you're not make sure you like uh don't yeah, make sure like there are like some subtle bugs that might happen. And then question 3, I guess there's a lot of parts to question 3, and I'd say it's like probably a bit hard for silver. Probably more representative, something that could be fair game for gold. Yeah. And then question 2, it's implementation heavy, but I think uh it might be fair game for like a harder silver problem. And then yeah, I guess one thing about problem 2 is I don't know how people felt about this, but um it could maybe be a bit difficult to like once you know it, it's like not that bad, but it could maybe be a bit difficult to come up with the observation for how do you order the points. Uh, Yeah. So I'd say this is probably harder than most silver contests, except for problem 1, which uh seem to be like similar difficulty. Um, And after you get past the barrier where how do you order the points? I think problem 2 is probably also like doable. Yeah. I'll take any other questions. Yeah, but yeah, this is probably a pretty good contest to upsolve. Yeah, you can learn a lot from upsolving, and yeah, just mistakes you made in the contest. You can learn how to not make them again. Yeah. How long was your code for this problem? So I didn't code problem 2, but I coded 1 and 3. Yeah, but I imagine it would be like there are like a lot of details you'll have to handle. Do you think silver has gold level topics on it? Um, I'd say uh maybe I think for problem 1 and 2, I think the topics in those problems are probably similar to yeah, for problem 1 and 2, it's probably similar to topic wise to a normal silver problem. I'd say in problem 3, maybe the ideas that are used there are similar to ideas that are used in more advanced problems, such as longest common prefix. Um, like I'm kind of going into some certain reads here, but um yeah, so I think yeah, like I've done problems in the past using suffix arrays. You don't need a suffix array. It's like a data structure used for strings. You don't need suffix array for this problem, but a common thing that you do is with suffix arrays is like longest common prefix. So I think like having familiarity with that, or like thinking about using longest, computing how to compute the longest common prefix, um, gives you like intuition how to solve this. Yeah, but I still think uh technically the ideas are like really maybe the monotonic stack thing might be gold level, but um I guess it's a mixture of dynamic programming, monotonic stack, and like being able to add a range, add add like a number to a range, and then maintain the value at its end. I guess those are like the three techniques that were used. Yeah, I'll take more questions. Yeah, but I'll just say don't get too discouraged if you didn't do well in this contest. Yeah, I think upsolving this contest you'll learn a lot. Since there are a lot of different things and ideas that were used in these problems.
Okay. I don't think we have any more questions. So yeah, so that's gonna be the end of our Go US Open workshop. Thank you so much to Urban and the rest of the presenters for speaking today. And yeah, it's like 8 p.m. So have a great evening, everybody. Thank you. Oh, and if you still have any questions, then I think we'll still be around to answer any.